Hi everyone, in this video, we are going to talk about an easy way to draw before and after graphs, or if you want to compare two groups with two factors. So first of all, let's install a package that is named as rstatix. So it's rstatix. So if you run that line, it will help you install the package. We need this package because we need a data set from the package as well as the function from the package. So once you install that package, make sure you load that package so the function, the data set will be ready to go. So the data set we're going to explore is called tooth growth. So if you type tooth, this data set will pop out. You can see this is the effect of vitamin C on tooth growth in guinea pigs. So this is actually a data set that is that is from experiments. Like we're checking one thing you can do is to run the question mark of the data set so that you can see, okay, this is a data set about the length of tooth growth in 60 guinea pigs. And the differences of the guinea pigs are the dose levels of vitamin C as well as the delivery methods. So if you see the printout in the console of my data set, you can see the data has 3 columns. It's a tidy data because each column is actually one variable. So the first column is the numerical length, and then the dose of vitamin C. The delivery method. So they have orange juice or VC, and then the dose of the vitamin C. So now we have the data set, we can try to explore the data. So the first thing you can do is to generate a frequency table, which means you can create using table function and then type tooth growth with one of the factors and then tooth growth with the other factor. So if you run this table, it will generate the frequency table for you. Frequency table tells us like how many guinea pigs we have for each combination. Like 10 means we have 10 guinea pigs accepting 0.5 dose levels of vitamin C through orange juice. So same thing, that 10 is through orange juice, but 1 dose level. So that means we have a balanced study because we have the same number of guinea pigs for each combination of the 2 factors. So the next thing we can look at would be maybe one thing we can do is to change the let's do a quick summary of the data. So one thing you may want to focus on is the dose. The dose are just those levels, and these 0.5, 1, and 2 are not really have theoretic numerical meanings. So you can run the summary function on the whole data set. So you can see length is definitely numerical, supplement is, and the dose is not really. So that's a problem. So the next thing we want to do before we draw any graph is to change the dose to a factor. So as we said, those levels are factors. Like we are really checking how does the factor the 2 factors affecting the length of the tooth growth. So let's change that dose to a factor by using a factor function. So for this, we are just replacing that original dose with the new dose. So the function we are going to use is called factor. and then we get the data of those, and then we change the levels to, we collect the levels of 0.5, 1, and 2, and then we give the names for these levels. We let labels equals, we can let it to be D.5, D1. So those quotation marks are making them names, not numerical values. So you can see this factor function is actually creating the levels of the factor, and we gave them label names for each level of the factor. So now if you run the summary function on the data set, there may be a change. See, we can see the dose we have for each dose level, we have 20 observations, 20 guinea pigs. So that makes more sense now. And then let's try to draw a graph showing all the data we have. So if you look at here, we have 60 observations with 2 factors. One factor has 2 levels, so the other factor has 3 levels. So that cool package we're going to talk about is called GGPUBR. So this is the specific package we're going to use. You want to install that package first, and then load that package to your RStudio. So only if you didn't see any error message, warnings are fine. And now you just load the package, and the next thing we're going to do will be the last thing, which is a function called boxplot. And we let the data equals tooth growth, click that. And then one factor we are going to use is called, so I just want to drag this data set up. So one factor we are going to use is called dose. And the other factor, I'm going to let it to be to direct the color. So the other factor is called SUPP. So I'm just going to let color equals SUPP. And again, when you draw a graph, you need X and Y, right? So we let the values to be the length of the tooth. So you just type LEN in there. And that's about it. So let's just run this line and see what happens. Click. And there should be a before and after graph. So similar to our before and after graph, as you can see. This graph actually visualized different doses with different ways of taking the vitamin C. You can see from the box plot, there are some differences, right? And if you want to be more creative, you can change the color of your before and after, because sometimes you may have, you may want to be creative. You may want to use the color to indicate what you are talking about. So in that way, you would change the palette. Equals, for us, we have orange juice and VC. So I'm going to type the colors to be orange and then yellow. So let's use orange and yellow for now, and then run that. So you can see the colors are specified, and you can be more creative, use the color to indicate what you're talking about. So if you don't like the yellow, you can use maybe blue, and you can see this picture is looking awesome now. Yeah. So same sense, you can be more creative only if you have a value and 2 factors you want to consider. And that's it. Thank you.